In HCI, interaction techniques are often evaluated with controlled experiments. For more complex experiments, creating a trial table is difficult. Manually creating a trial table is tedious and prone to errors. Software tools for designing experiments such as Touchstone introduce a step-by-step procedure to automatically generate trial tables. But exploring different design alternatives remains cumbersome. We present the Touchstone2, an interactive environment for exploring trade-offs in HCI experiment design. Let's design a Fitts-Law experiment to compare three devices: mouse, trackpad, and joystick. We want to compare them at 5 levels of index of difficulty. Designing an experiment with Touchstone2 involves assembling the experiment in the workspace. The preview of the trial table appears on the right. Underneath is a statistical power chart and context-sensitive help. Touchstone2 shows the required number of participants and the experiment length under each design. This design requires a multiple of 1 participant. To prevent order effects, we change the counterbalancing strategy to Latin square. This increases the required number of participants to a multiple of 15. Since 1 participant covers less than 7% of potential order effects, we increase the number of participants to 15. Fisheye views help inspect the full trial table. We see certain patterns highlighted, such as the distribution of one level of the input technique. In this design, participants must constantly switch devices, which is inconvenient and lengthens the experiment. To save time, let's try creating an alternative design that reduces switching. The context menu lets us duplicate and rename the current design. We choose blue for the color in the statistical power chart. We drag a new experimental block from the toolbox and add it into the new design. We move index of difficulty into the new block and set the counterbalancing strategy to random. The preview on the right shows that the devices are grouped together. This design is suitable for a multiple of 3 participants, including 18, 21, or more participants. The power chart lets us explore the relative benefits of having more participants. The number of participants appears on the horizontal axis, and the statistical power appears on the vertical axis. As the number of participants increases, power also increases. The dots on the line mark the possible numbers of participants based on counterbalancing. The red area marks the 80% power threshold. Experiments that pass this threshold are considered powerful. If an effect exists in the population, higher statistical power means we are more likely to detect it. The relationship between number of participants and power depends on our estimate of the effect size. Smaller effects require more participants for the same level of power. We can check how 3 conventional effect sizes influence the power curve. Or we can specify an effect size from the literature and adjust a degree of uncertainty. We can also calculate effect sizes from pilot studies. Based on the pilot study data, we would need 33 participants for 80% statistical power. Touchstone2 lets researchers explore and compare different experimental designs and compute their statistical power.